Welcome to CubeWorks. Right now, in office buildings and factories across the Philippines, air conditioning systems are running at full cooling capacity in completely empty spaces. Nobody authorized it, the rooms are vacant, but the chiller is running, the air handling units are blowing, and the electricity meter does not care. It does not realize the production floor cooled down early because heavy equipment was turned off. Because it lacks this contextual awareness, the system over-conditions unoccupied spaces, undercools crowded meeting rooms, and maxes out your energy profile during peak hours unnecessarily. To put hard numbers on this, for a standard 5,000 square meter commercial building in Cebu, HVAC easily consumes 467,000 pesos a month. Achieving a 23% reduction through intelligent control recovers over 107,000 pesos monthly. That is 1.29 million pesos a year in savings. That 23% benchmark is not theoretical. It comes directly from real-world Philippine deployments and aligns with published ASHRAE industry research, which consistently tracks 15 to 30% savings when moving away from fixed schedules. A fixed schedule locks you into paying for cooling you never use. True energy profitability requires shifting to responsive, data-driven control. Smart HVAC optimization begins with a simple rule. You cannot control what you cannot measure. To achieve this, we establish a physical measurement layer using 4 specific data streams. First, we install dedicated temperature and humidity sensors in every major zone. Second, we deploy energy submeters on each air handling unit and chiller. Third, we capture equipment status by integrating directly with your existing building management system or through detailed direct I/O monitoring. Finally, we install physical occupancy sensors in each defined space. We unify these 4 distinct data streams into a single industrial IoT platform. As you can see in this sensor overlay, the system now sees the exact environmental and mechanical state of the building. We know who is in which space, the precise thermal condition, and how much power is being drawn to maintain it. This specific measurement layer pulls a building out of mechanical blindness. It makes the facility contextually aware, which is the absolute prerequisite for automated intelligence. Once active, the data consistently reveals 5 specific, costly failure patterns within the first 14 days. Pattern 1 is conditioning after occupancy ends. The system runs for hours after the last person leaves, because the static schedule doesn't know the room is empty. Pattern 2 is set point creep. Meeting rooms are dialed down to 17 degrees. Every degree below optimal forces a 5% penalty on cooling. Pattern 3 is invisible chiller degradation. The central plant draws massive power while producing a fraction of its rated capacity. Pattern 4 is supply air temperature drift. Air leaving an AHU drifts above set point, forcing the chiller to work harder. Pattern 5 is simultaneous heating and cooling. Perimeter and core zones actively fight each other, wasting energy on both sides. These 5 mechanical failures are entirely invisible to standard BMS schedules, yet they are draining massive portions of your monthly operating budget. If you want to stop that financial drain, you have to look at the single most expensive component in your facility, the chiller. We measure chiller efficiency in kilowatts consumed per ton of refrigeration, or kW per TR. A healthy water-cooled centrifugal chiller might run at 0.55 kW per TR, but if it degrades and operates at 0.82 kW per TR, it is consuming 49% more power for the exact same cooling. Take a look at this trend line tracking a chiller's efficiency over 18 months. Notice the creeping upward trajectory from the baseline. Running at a continuous 200-ton load with this 49% excess power draw means you are burning an extra 49 kilowatts every single hour. The mechanical culprits are specific: condenser tube fouling, refrigerant leaks, or compressor wear. Left unchecked, this degradation creates over 5.1 million pesos in wasted energy per year. But because IoT trend tracking detects this early, you trigger a targeted maintenance intervention. The graph shows immediate recovery back to baseline efficiency. Relying purely on calendar-based maintenance contracts results in a predictable stream of silent, unrecoverable losses. The same over-engineering problem applies to how we move air. Conventional ventilation pumps fresh air regardless of how many people are inside. Demand-controlled ventilation eliminates this waste by using CO2 sensors as a proxy for human presence. According to ASHRAE standards, indoor CO2 should stay below 1,000 parts per million. As a room fills and levels rise, airflow increases. If the room is mostly empty and levels drop below 600 ppm, ventilation slows down. This is the continuous feedback loop that makes it happen. The CO2 sensor publishes data to the IoT platform, which automatically commands the variable frequency drive on the air handling unit to adjust fan speed in real time. We expand this logic using occupancy sensors. When a zone is completely empty, the system automatically triggers a standby mode, maintaining a minimum temperature to avoid thermal shock, but stopping active cooling entirely. By dynamically matching your mechanical output to real-time human presence, you eliminate the structural overconditioning that plagues legacy HVAC designs. Deploying HVAC IoT delivers a predictable return on investment. Phase 1 focuses on monitoring. Over 3 months, we generate a hard baseline of how your building operates. In Phase 2, we execute schedule optimization, yielding 8 to 15% immediate savings. Phase 3 introduces automated control, driving an additional 10 to 20% reduction. Phase 4 is ongoing optimization to ensure those savings persist. For a standard 5,000 square meter building, against annual savings of up to 2.5 million pesos, the payback period is incredibly short, just 2 to 4 months. An investment in IoT visibility functions as a rapid, self-funding operational upgrade with a return calculated in months rather than years. Right now, your building's air conditioning is running, and without an active data layer, you have no verified proof of whether it is running efficiently or just burning capital. You don't know if your chiller is hitting its 0.55 design rating, or if mechanical degradation is silently costing you millions of pesos in excess power. Visibility creates control, and mechanical control creates significant, measurable financial savings. Your immediate action costs nothing. Identify who manages your facility's HVAC schedules today and audit those schedules against your actual physical occupancy patterns. Next week, we are analyzing power quality, specifically how harmonic distortion from variable frequency drives is degrading your equipment and inflating your energy bills. Subscribe to KeepWorks. Don't let your HVAC budget run blind.